SwayamPrabha. Digital India. Educated India.
Hello and welcome to this Manufacturing Systems Technology Part 2 course, today being Module 1. Just a brief recap of sort of what we did in the Part 1. We tried to learn about computer integrated manufacturing systems, really, starting with the CAD design part, then going into the different aspects of how you do process planning, and then finally also trying to write a code using numerical control on machines, and then finally studying a little bit about inventory management, keeping the lean manufacturing concepts into mind. This particular module would be dedicated more on issues like quality associated with the manufacturing process. It will also be looking into various aspects of material handling systems like let's say automatic storage retrieval systems or automatic guided vehicles, AGVs, which are the most important concepts of production management in the current technology regime which exists in the industries. We will also look in details to some of the issues related to robotics and robot programming in this particular module. So let's talk about quality. Quality really is the key parameter that is determinant of whether an enterprise can be in business. Okay, gone are those days, probably the late 80s, when we used to talk about minimum cost, and also to some extent about the lead time in which production processes would be able to converge and realize a product to the customer. The major issues which are nowadays very important to stay in business is how repeatable the performance metrics of a product is once it goes to the customer or the market, and the whole essence is about changing the quality management philosophy of an organization and changing the focus of management of an organization geared to the quality aspect, so that there is no value, no non-value added work which comes out of any process. So push back as far as possible the metrics which determine the quality into the process, so that at the stage of the process output you really need not worry about the quality level. Okay, so this is all called in-process quality build-up, and all the organizations nowadays are more or less intending to do that. So let's understand how quality can be done at the product level or the process level, normally by designing the process of the product and introducing a lot of robustness in that design stage, so that the non-conformability or the not meeting of the performance metrics is out of the question, okay, of given a product design or given a process design which has been laid out. So that's the essence at which we will be looking at of this quality engineering aspect. And let us look at some of the basic principles which are important for understanding quality. So obviously the best approach, as I think I had illustrated, of product quality is to build quality into the product and process right at the product and process design stage. Okay, it's called robustness by design. And also it may be improved at the production stage by confirming to the process design and trying to see whether whatever you have laid out as your process follows the norms for the process at every stage, the norms that have been formulated at the design stage of the process. So for this purpose, the techniques such as SPC or SQC, which is also known as statistical process control or quality control, is used, and the idea is that you have to somehow be able to reduce the number of non-conforming products and non-conforming parts which come out of a production process. Okay, so reducing the number of non-conforming products and thereby improving the quality is basically the goal. So one aspect obviously is the design stage, and one aspect obviously, as the production is going on, what do you do to arrest the production problems at a much earlier level before it really gets into a menace. So that's all about quality engineering. And if I really looked at quality, it is really a relative term. Some person may perceive something as high quality, some person may perceive something else as high quality. So you have to have some kind of a customer mapping of the customer needs and the aspirations that the customer has behind the product exactly into the product. Okay. So obviously we did a lot of this analysis before when we talked about how variability can be introduced at the production process stage, given the change of perception, how quickly a process can be altered to produce something which changes or maps that perception on a real time basis. So all this we did in part 1, manufacturing systems technology. So here it is really dependent on the eyes of the beholder, I would say, who is the customer, who would actually try to treat quality in some particular manner. So from a functional point of view, of course, the product is considered to be good quality if it meets the desired functional requirements adequately over the intended period of its use. Okay. And so the definition of the quality as per the American Society of Quality Control includes all these concepts which have been illustrated here, and says that quality is the totality of features and characteristics of a product or service that bear on its ability to satisfy a given need, and need means customer need basically. So how well you are conforming to the characteristics as mapped from the customer need is what the quality means philosophically. So if I look at some of the dimensions which are associated with the let's say quality of the product, there are principally about 12 dimensions related to the product into which you can categorize the quality of a product. The first being the performance, of course, is the primary operating characteristics. We are talking about, let's say, the engine meeting a certain brake horsepower output. So the primary operating characteristics of the engine then would be how much BHP the engine is designed for. Okay. Or let's say, for example, if I wanted the flow rate coming out of a let's say a mechanical pump, then the flow rate would be the primary operating characteristic for which primarily the product is intended, the design of the product is intended. So that is the performance, the primary operating characteristic. The other aspects are features. For example, there may be many secondary operating characteristics apart from the primary operating characteristics. For example, in an engine, if we look at, let's say, the secondary operating characteristics, there may be many issues like, for example, whether the engine meets the emission norms. Okay. So that can be one of the secondary operating characteristics. Given the primary operating characteristic of the engine RPM or BHP, which is very, very critical, okay, the next need could be that, okay, is it going to meet some kind of a quality layout for meeting the emission norms. Okay, so that can be a secondary operating characteristic in this particular case. Okay, so then you have, of course, time waiting in line, time from concept to production of a new product, time to complete a service. These are all a very important part, that how much lead time you are having in the process, which includes probably the design concept all the way to the production stage of a product. Or let's say when you are talking about a service industry, time to complete a given service, like for example, when you talk about a restaurant and you want to see how the food from the ordering point to the point when it is delivered is taken across, so all that time would be considered as very critical, because the customer may have to wait more or less depending on if the food arrives faster or later. Okay, and so that's a very important aspect of quality. So performance, features, time. And the next is reliability, the extent of failure free operation. For example, let's say when you're talking about the Indian driving cycle, we might as well see that if, let's say, there is a quality parameter on an oil seal and an engine, and you want to simulate the engine to run on conditions like the Indian driving cycle, and see that how many revolutions of the crankshaft can this oil seal bear without leaking. Okay, so that's the reliability of the oil seal. So something which is more related to the extent of time up to which the product would operate without any failures. That is a very important part of the quality. Durability, again a very important part, amount of use until replacement is preferred to repair. We all talk about product warranty and product guarantee, in some of the cases where there is this issue of durability which is talked about. So can you, up to what amount of time you can use the product, right, until the product really becomes so non-conforming that you will have to rather replace it rather than doing some changes and trying to use it. Okay, so that's the durability. Obviously, uniformity is an important quality dimension. So, low variations among repeated outcomes of a process. We are talking about, let us say, production of a circular shaft, a cylindrical shaft by turning process, and there the the uniformity could be concerned with what is the variability in the output dimension, that is the diameter of a particular shaft. Okay, if you are producing 20,000 such shafts in maybe a day's time on a high speed NC controlled lathe machine, then the question of uniformity would come as to, if you look at all the outputs, is it all coming out to be within the dimension plus minus the tolerance which has been provided in the design itself, or is going out, the process is going on a run out. So that is the uniformity, that is a very important aspect or dimensions of the quality. Consistency. Okay, so consistency basically talks about match with documentation, advertising, deadlines or industry standards. So whatever has been planned for the process, be it the production process or the marketing process or even the design, first principle of quality says that document everything that has been planned. In fact, all the different related certification agencies are basically nothing but overall guidelines of how to document certain processes or certain products or certain systems within an organization. So this documentation, once done, has to be matched at every level consistently. That is called consistency of a organization, that if you have documented a process to do or carry out in X or Y way, are you sticking to that process or sticking to that documentation as far as the regular running of the process is concerned year long, is something which is related to the consistency. Okay, so this can go true for even things like the deadlines to an organization, how the deadlines are being met, how you are advertising for the particular product that the organization produces, or are there any industry standards which are there and you are complying to them. So these are all part of consistency. Serviceability. So obviously there may be product failures in the market or product non-compliance or non-compliance of the performance metrics in the market, because of which frequent servicing may be required of the product. Particularly for dynamic products, it's very important that once sold, you have to have a sort of annual maintenance of these products to set it right every time and set it and ensure that it keeps running. For example, if you buy an automotive, there is obviously a service plan given with the automotive that you will have to come after so many kilometers or so many number of days back for service, and there may be some free services given by the organization just to ensure this habit of quality checking to the customer and ensuring that the customer returns once in a while, so that the overall vehicle health can be monitored at that particular level. Okay, so the serviceability of the product is a very, very important dimension of quality, and this has to be planned at the design of the product stage. You're designing a product which is unserviceable. Let's say, for example, after the full assembly, you're not able to open a part from a system. It's a major problem. So the other issue is the aesthetics of a product. Obviously, as the name implies, it means how beautiful is the product in its make or construction. So it's basically all characteristic related to qualitatively to the senses of the customer, and it is basically a mapping of how he perceives a product to be a good looking product. So that's what the aesthetics means. It's a very important trait of quality, again incorporated in the design stage for a product, so that there is good amount of perception about the product in the customer's mind. So obviously there is a personal interface which talks about characteristics such as punctuality, courtesy and professionalism. For any particular organization, this is a very important aspect that related to, let's say, a process for an organization or related to for the systems for the organization. Are the essential elements of that organization the human factor? Is it really disciplined and punctual? This would be very important for determining whether the overall quality level would be afflicted of the particular product. Okay, or maybe make systems in a manner so that people become regular and punctual. Then you have things like how professional a person is about his own work. For example, does he hide anything which goes bad in the production that he has made, or the sequence of operation that he has added on to a certain system or a product. Okay, so this is also a very important, the trait, the personality trait of a person who is involved in the production level is inherently related to the quality. So this is a personal interface of the human force which is associated with production or even the design, is very important dimension of the quality again. So for example, in systems, in places where you can ensure that the workforce by and large is disciplined and the workforce by and large is honest about what they are doing, you will always be able to get a good level of quality. Harmlessness. So obviously this is the characteristics related to safety, health and environment. Any process, for example, which is the production process, will have an issue related to overall safety, okay, whether this particular product, when the production process is going on, is safe to be produced. There may be products where toxic fumes or harmful vapors may be generated, which may not be that consumer friendly, or which may not be that friendly to the personnel who are making the product at that particular stage. So you will have to make separate guidelines for sort of environment protection there, so that the human safety aspect of the people who are involved directly in the production can be taken up. And so this has to be again a important part of process planning, and so that would in a way influence the quality of the products. So for example, in automotive paint shops, if you have a certain level of, let's say, environmental cleanliness, it is very important for the quality of the particular product. If there is a certain amount of dust level, let's say for example, if we are talking about a paint shop with class 1000 or class 10,000 cleanliness levels, where we are talking about how many dust particles per millimeter cube or ml of air is available in the particular system. This is a very important concept of quality, because it is related to the environment in which the product is being produced. Okay. So the harmlessness and also issues related to the environment are very critical for the product quality. Obviously perceived quality again is a very important factor, which is actually an indirect measures or inferences about one or more of the dimensions and then overall reputation, etc. of the business. So if I am well known to produce a high quality product, so the perceived quality just by looking at that particular brand of the product will be that yes, it is good, So that also in a way is a dimension to the quality which needs to be promoted at the design stage itself. So these are the various, I would say, 1 to 12 dimensions of quality which are important for ensuring that there is a quality system in place within an organization for the process or even for the product design. So we will stop this module here in the interest of time, and in the next module we will look at some of these the costs which can be associated at various stages, which can be a sort of penalty cost to any non-compliance to the quality standards which have been laid out in the process design itself or even in the product design itself. So if we have this cost approach, then everywhere you are doing some kind of a non-conformance, there would be a penalty, a cost penalty. So this the idea is that the conformance level would be high in that particular case. So this is the concept with which we will move ahead in the next module. Thank you.